In this example, I'm going to show you how to find the center, the vertex, and the focus, and then graph the ellipse. So here's a problem. This is the equation of the ellipse in the general form. Our goal is to rewrite this into the standard form with the vertex h and k. So let's go back to our lesson. Our lesson here, right here. We have standard equation of the ellipse. This is for the horizontal axis when our ellipse is horizontal, and here's the equation. So we have to rewrite our problem to look like this, or to look like this when we have vertical major axis, or our ellipse is vertical, or look like that. So we have to do that, we need to complete a square. So our goal is to rewrite to the standard form by completing a square. We have x and y, so I'm going to group all the x together. Then we're going to group all the y together. Now because 21 had no x, no y, so we move 21 to the other side by minus 21 both sides. So I have a minus 21. To complete, now we go ahead and complete a square. Now to complete a square is easier if we have the number, the coefficient that multiply by x squared or y squared is 1. Since I have 4 here, I'm going to factor out the 4. Okay. Now remember, to complete the square, we need one more term here because we want this one to become a perfect square. So I leave a space there and for the y, and just copy it down. And I add one more term. Okay. Alright, so let's do that. Do the square. To complete the square, we always take this number with 6 divided by 2 equal to 3, which is stand for b, because we want to have a minus b squared or a plus b squared. These are the perfect binomial square, and we want to rewrite these to look like either that or this. So now in the square, this equals, we square the 3, we have 9. So I add 9 here. Right. Now we actually not actually add 9, we add 9 that go inside here, but the whole polynomial here multiplied by 4, so we actually multiply 4 of the 9. So we actually add 4 times 9, like that. Over here we do the same thing. I take 2 divided by 2 equal to 1, and then 1 squared is equal to 1. In this case here I add only 1. So let's rewrite my problem. So I have this here, we can rewrite to look like this, where a is x and b is 3. So I have x, the plus here dictates to put the plus right here, 3 squared plus. And then this for y, I can rewrite to look like this, where a is y, b is 1. So I have 1, y minus 1 squared equal to, I take 21 plus 36 and plus 1, I have 16. Okay. Now, by the standard equation of the ellipse, I must have 1 over here. So to make our problem equal to 1, I'm going to divide by 16. Divide everything by 16. And then we're going to simplify. Four divided by 16 is, they cancel out right here, have 4 left right here, plus y minus 1 square over 16 equal to 1. Okay, when I'm done this, I'm going to go back to my note and see which one do I have. Okay, I have something like these, or like that. So let's see. So I know my h and my k right away. So I see that my h is minus 3 and my k is 1. Okay? Because the y square has a larger denominator, therefore the major axis is along the y-axis. So the y-axis will be parallel with our major axis. Okay, therefore a square equal to 16 and b square equal to 4. Remember, a square always greater than b square. Therefore, I take a square root for a square and b square. I have 4 here, and b I have 2 here. So our center, the center will be h comma k, which is minus 3 comma 1. And this, I have that. I'm going to go ahead to find c. Okay, so because c is where it will tell me where is my focus is. So I'm going to have to find c first and then the graphs. So I know that I found a center. I pretty much know from here I can find the vertex later on, but I'm not worried about it. Looking for c. c actually equal to the square root of a square minus b square. So I'm going to have, that's for my notes, based on our notes here that I know that's right here. That a square minus b square. So we have the square root of 16 minus 4. So I have a square root of 12, which is equal to 2 times a square of 3. Remember, 12 is then for 4 times 3. The square root of 4 is 2, and a 3 left inside the square root. So that is our c. Okay. So I pretty much have very good information. I'm going to graph this a little bit, and then the rest will follow. Okay. I just wanted to go down a little bit. Oop. So I just adjust my graph. I know our center is minus 3, 1. But here's our center. And we know that A is 4, B is 2. But we have a vertical ellipse because our y square term had a larger denominator. So I have vertical ellipse because my major axis along the y-axis. I have vertical ellipse. So I know that from there I extend 4 units up, and then we extend 4 units down from the center, which is minus 3, 1 right here. So from 1, 2, 3, 4. So right here is my center. Okay. So our center, here's our center is minus 3, 1, and our vertex. Our vertex will be a minus 3. And then I go 1, 2, 3, 4, 5. And then minus 3. I go down, okay, 0, 1, 2, 3. So that is out, gives me minus 3, our vertex. Okay. You can, if you like, you can always use the formula that I gave to you, but I'm kind of person don't like to renumber formula if I don't have to. Okay, here's the formula. I know h and k. I can add a minus a to the k value because I have a vertical ellipse, or just do my way. I know my center here. I know that a major axis along the y-axis, I mean, go this way. It's a vertical ellipse. So I go 4 units up and then 4 units down. I have 2 points as my vertex. Then B is 2. That means I go from the center 2 to the right, then 2 to the left. This will help me to draw my ellipse. So I'm going to draw a box here, my imaginary box to help me out. So right here is our vertex minus the point minus 3, comma 5, and minus 3 is our vertex. Now we pretty much can draw our ellipse, but we have to find our focus. Now our focus should be from here. I go C unit up and C unit down. So the point will be minus 3. And then our C is 2 times square root of 3. So right here is our center, minus 3, comma 1. Our center, our focus is along the major axis. Right here is our major axis. Right here is our minor axis. Here is our minor, and here is our major axis. So the point that will be B1 is our K plus C, which is 2 times square root of 3. And then I have another point down this way, so we have minus 3, then 1 minus 2 square root of 3, because this point here is K is 1. I go from 1 go to K unit down, and then from 1 go to C unit up. Here's the K is 1, excuse me. K is 1. So C is where it tell me my focus is. So I'm go from 1, from K, go to up by C, and from 1 go down by C. So I want to know approximately what is 1 plus 2 times square root of 3 is, so I can graph my focus. So I'll take the square root of 3 and use my calculator. So what I do, I put this value in the calculator. I'm looking for approximately which is equal to show me the graph. So I take this 1 plus this equal to approximately 4.5, and 1 minus 2 times square root of 3 is approximately minus 2.5. So our focus should be, let's see, 1, 2, 3, 4, 5. So right here is 4.5. That is our right here is our focus. And the bottom here have 2 minus 2.5. So here's 0, 1, 2. Here's 3. And 2.5 is about here. So that is our focus. So now I'm going to graph my cycle. Connect this to here, this to there, and then here. See. Remember, right here is our major axis. This is 4 here and 4 here. Here is 2, here is B, and 2 here is B. This is our minor axis, this is our major axis. Here's our focus, right here. Lie on the major axis. Here's our vertex. That's it.